Now let's take up this question. It says the population of a town is 60,000. That is given, is the initial value. In the first year, it increases by 20%, and in the second year, it increases by 10%. Find the net percentage change in the population in 2 years. Now, one thing that you have to assume anyways, always by default, that whatever is the percentage change in the population, it is always on the existing value. So it is compounded, right? Let's try and understand. So initial population, here it is given 60,000. There are many ways of doing this question. First, I'll take this method. In the first year, what is happening in the first year? This value increases by 20%. So what you need to do is calculate 20% of 60,000. How do you calculate? Let's see. What is 10% of 60,000? It is 6,000. 100% is 60,000. So 10% is 6,000. So 20% will be 12,000. This 12,000 is the increment which is added to 60,000. So it becomes 72,000. 60,000 plus 12,000. So it becomes 72,000. This is the population after 1 year. Now what will happen in the second year? Let's see. In the second year, the population increases by 10%. As I said, by default, the next change will happen on the new value, and it will keep on happening like this. And that is why I said compounded. Okay. Population is always calculated compounded. So 10% of 72,000, 100% is 72,000, so 10% is 7,200. So 7,200 is the incremental value in the second year. This will get added to 72,000. So the final value will become 72,000 plus 7,200, that is 79,200. So this is the final population. Now what is the question asking? Net percentage change in population in 2 years. So this is our initial value 60,000. Our final value is 79,200. So the net change will be calculated from here to here, right? So straightaway we can say net percentage change is equal to final value 79,200 minus initial value 60,000 divided by initial value, that is 60,000 in 200. Now 79 minus 60 is 19, so it is 19,200 divided by 60,000 into 100. So 1, 2, 1, 2, 1, 2, 1, 2, zeros are cancelled. 6 cancels 192 32 times. So the final answer will be 32%. So the population has increased. We must say that it is increased. Net change is 32% increase, right? Now points to note. This is 32, whereas here in first year it has increased by 20%, second year 10%. The simple addition of 10 plus 20 is 30, whereas the answer is more than 30. How did it happen? Because it only happened because this 20 and 10 cannot be added. They cannot be added directly. Why? Because they are not being calculated on the same base. For this 20%, base is 60,000. For this 10%, base is 72,000. You can add percentages only when they are calculated on the same base. Alright, here they are not being calculated on the same base. Okay, so be very careful. Answer is not the simple addition of 20 and 10. It is successive addition. We will have one more method right now and one more method later on. Right, so let's take one more method here. Here the question is saying initial population is given. Now suppose this population was something different. Let's say some difficult number, 67,283, and still 20 and 10. Then what do we do? Right? In those cases, and even in this case, we'll apply that what we did in the school question where we had 1200 students. We'll apply the same method. We will assume the initial value to be 100. The other method to do the same question is, let's see. Let's assume the initial value to be 100. And I repeat, irrespective of the value given, whatever is the value given, just ignore it. Let's assume that the original value is 100. Okay, and then apply these changes here. So in the first year, then follow the same procedure. The benefit of this method will be whether it is 60,000 given or some difficult number given, it doesn't matter, right? Because the answer will depend only on this 20 and 10. Let's see. So initial value 100, right? In the first year, it increases by 20%. So how much will it become? 20% is calculated on 100, so it is plus 20. It is added, so 100 plus 20 is 120. Now in the second year, what will happen? 10% is calculated, and this 10% is on the new value, 120. 10% of 120 is 12, so add 12. So 120 plus 12 is 132. This is the final value. And as you can see, directly the net percentage change here is final value minus initial value, that is 132 minus 100, divided by initial value 100 into 100. Even if you don't do this, you can directly see that the answer is 32%. So that is the benefit of taking 100 as the original value. So this will always be one very prominent method, that we take the original value, the base value is 100, and then we do all the calculations and find the final situation. Alright. And as I said, there is one more way, which is a formula method. And here we'll introduce one more topic, that is called successive change. Okay. So successive change method. For this successive change method, we don't even need to consider the original values. Right. The only thing is, one thing that has to be very clear, that the changes have to be successive, right? Because if the changes are not successive, they are on the same value, they'll simply get added, okay? In this case, changes have to be successive. So if the changes are successive, as you can see in this case, they are successive. How? First this 20% was calculated, then there is a new value. On the new value, the next change is conducted. Now next change is calculated. So if this is the situation, the successive change method can be applied. How is it used? Look at it very carefully. If the two successive, also one more thing, this formula can be applied only for two successive changes. As in this case, there are only two successive changes. So if the two successive changes given in terms of percentages are A% and B%, then their net change or net percentage change, their net percentage change is straight away given by A plus B plus A into B by 100, this much percentage, right? See, if they are conducted on the same value, then answer will be simply A plus B. But if they are successive, it will be A plus B plus A into B by 100. You have to be really careful about the sign of A and B. If A and B are increments, they will be positive. If A and B or any one of them is decrease, they have to be taken as negative value. That's it, right? So if you apply in this case, here A is given as 20%, B is given as 10%. So straight away their net successive change or net percentage change in this case will be 20 plus 10 plus 20 into 10 by 100. Alright. So 0 and 0 cancel. This gives us 2. 20 plus 10 is 30 plus 2 is 32%. So this is one very beautiful situation that this gives us. So there are three ways of doing. One, we take the original value. Obviously this is not very preferred method. Second, this one will be like always a default method. It will always be useful. And in some cases you can directly apply the formula. In fact, a lot of cases you can directly apply the formula only if you know the component changes. So if you know the component changes, if they are successive and you know their sign, whether they are positive or negative, you can directly find a net change using this formula A plus B plus A into B by 100. Remember, only two changes, right? If there are three changes, then what do you need to do? First, find the successive change of, let's say if there are three changes ABC. First, find the net change of this, let's say it is X, by using the formula A plus B plus AB by 100. And then take X and C as a successive to find the net change of X and C. That will be the net change of ABC, right? But in that case, I think this 100 wala method will be more useful.